The topic of this video is on volume. And while volume has been a previous standard, it is one that we're just going to kind of recap how it works. So you can kind of see that there is a key here at the top for what these variables mean. And then you can also see the breakdown. So on the left-hand side here, you've got your area and circumference formulas. And on your right-hand side, you've got all of your volume formulas. So a few things to note. A capital B means the area of the base, okay? So you'll have to figure out what is the base of the figure and then find the area of that, so using these formulas over here, and then multiply it by its height. And so that's a key compartment to, or key part to the pyramid and general prisms. Really all volume is the area of the base times the height, except for things like sphere and cone and pyramids are a little bit odd as well, just because you have to take a third of them. But let's kind of, I try to pick one of each kind to try to break it down and explain it to you, just so that you can see how they work. All right. So the first three are all general prisms. All right. And a prism is something that is connected by rectangles. So if you can kind of see with my coloring here, we've got two shapes connected with this rectangle, connected with this rectangle right here, and connected, probably not that color, with this color right here. So there are two triangles connected by those three rectangles. This is a triangular prism. All right. And the base figure is a triangle. So I have to find the area of the triangle, just one of them, and then I can multiply it by the height, so the distance between the two triangles. So I can see that distance between the two triangles is 3. Okay, so I have an H value of 3, and now I just have to really look at my triangle to figure out what is the base and the height. Well, the base and the height of a triangle always make a right angle. So I'm going to identify the right angle. So I can kind of see that right here. This red line and this line right here is making the right angle. I can see the box right there. So that means that my other two numbers that I'm going to be using are those two. Okay, so for the area, I'm going to do 1/2 times 3.4 times 7. Okay, so I'm going to just type that into Desmos times 7. And that gives me that the area is 11.9. And then I would do 11.9 times 3, because this is the area of the base times the height, right? So the 11.9 times 3 gives me that the volume of this is 35.7. And that would be meters cubed, because I multiplied 3 things. I multiplied 1 thing, 2 things, 3 things. Okay. So sticking with the same formula, area of the base times the height, right? The rectangles in this case are kind of on the outside, right? And the two shapes, I'm just going to highlight the two shapes that are the exact same. It's this one right here and this one right here. So this is a rectangular prism, or a square prism, I should say, actually, because that's a square in the back there. And notice that these rectangles are round. They don't really matter right now. The only thing that really matters is how long this is, which I can see that's 2, because that's the height. Okay, so I have a height of 2, the distance between the two pink squares. So I have to find the area of the square, right? Which the side lengths are 1 times 1, which is 1. So I'm going to do the area, which is 1, times the height, which is 2. And this has a volume of 2 cubic inches. This is another triangular prism here, because rectangular and square prisms are the same, but triangular prisms can be a little tricky. So if you can see that these two triangles, these are the bases, okay? It doesn't matter if it's sitting there on it or not. It's the two shapes that are the exact same that are connected by rectangles. So these are the two bases. So that means I have to find the area of the triangle, right? So 1/2 base times height. Remember that the base and the height always make a right angle. So if I look here, I see the 2.2, 1/2 times, that's 2.2. The base, it looks like I have to look up to get that, and that's 10. Okay, so I've got that math that I have to do here, 2.2, which is 11. Okay, so this area equals 11. And so now that I have the area, I'm going to do the volume equals area of the base times the height. So area of the base is 11. And the height, remember, is the distance between the two. And that's 7. So this has a volume of 77 centimeters cubed. So I'm hoping that part makes a little bit more sense with the area of the base times the height aspect, because we are going to switch and do some pyramids here, okay? So our pyramid formula sticks with the area of the base times the height, but now we have that 1/3 idea, and that's because it comes to a point, okay? So the base is, again, that different shape other than the triangles that it's being connected to a point with, right? So this is my base right here. This is the area of the base. So if I were to find the area, that's a rectangle of the rectangle, right? That's just, if I look up here, base times height. So finding a 90-degree angle and calculating that. So that right here, that's my base and my height. So 8 times 10 is 80. This is my area. Okay, so volume is 1/3 area of the base times the height. So 1/3 times 80. And then the height is from the very top peak here straight down. Okay, and that is 10, it says. Okay, so I would do 1/3 of 800 essentially, which is 266.7 meters cubed. That would be the volume of that figure. Let's take a look. We have one more, okay? Again, remember, volume is 1/3 area of the base times the height, right? And the base is this bottom triangle down here. This is my base. So I have to find the area of that triangle. Remember, and I've said this multiple times, but I'm just going to keep saying it. When you're trying to find the area of a triangle, the base and the height always make a right angle. So if I find the right angle, it's right there. I'm going to be using these two side lengths, which they say are 6 and 8. So 1/2 times 6 times 8, that gives me an area of 24. Okay, so volume equals 1/3 times 24 times, I need the height. And the height is going from the center to the point. It's right here. And that, it says, is 9. So times 9. And that gives me 24, 72. So the volume of this is 72 meters cubed. There's my volume. All right, last two, it looks like, because I don't have a sphere. Okay, so a cylinder here is where we're looking here. So volume is pi r squared times h. So volume equals pi r squared times h, which pi r squared is the area of a circle. So really, we're doing the exact same thing. We are finding the area of this circle down here, and then we're multiplying it by the height or the distance between the two circles. So this is the exact same thing that we've been doing, but let's stick to it. So pi r is the radius, so 7 squared. And then if we multiply that, by the height, that's another 7. So let's type that in. That's going to be pretty large. This gives me 1077.6 centimeters cubed. That's a pretty large volume there. All right, last one is the cone, which the cone is the exact same as the cylinder, except it has that 1/3 in front. So the volume is 1/3 pi r squared times h. So same situation. This is the area of a circle times the height, and then because it's coming to a point, we have to take it to the 1/3. So the circle that we are looking at here is this one down here, right? That's the area of the circle. So that's pi times 10 squared. The height is moving down. Ooh, I take that back. Hopefully y'all just caught my mistake. Because the radius is not 10. The radius is 5, right? Because that 10 is the diameter. So pi times 5 squared, I apologize, times the height of 10, and then times 1/3, okay? So we have, this would give us a volume of 261.8 meters squared. So this would be our final volume right here. If we had a sphere, which I can't really draw very well, but let's say it looks like this, right? And let's say it has a radius of 6, okay? Your formula is 4/3 pi r cubed. 4/3 pi r cubed. So as long as you know the radius, this is just one of those plug-in pi, 4/3 pi, and then times 6 cubed. And you would type that in your calculator. So a sphere, the only extra complication you might get would be if they gave you the diameter instead and you had to half it, right? So let's say they gave you the diameter and they said the diameter was 6. We would just have to cut that in half and make that a 3. But that is, in a nutshell, how volume works. And these formulas up here are given to you. So you just have to be able to understand. I think the trickiest part are those area of the bases and identifying what the base is. But after that, I mean, you really can, you really just have to be able to look at the shape and plug them in correctly. If you have any questions, please don't hesitate to ask.